In this video, we'll be talking about stoichiometry. Now, stoichiometry is a topic that kind of combines our knowledge of dimensional analysis, our knowledge of moles, Avogadro's number, and chemical reactions into one. So our objective and essential question are to be able to predict the products and reactants from a chemical reaction by doing stoichiometric calculations. And the essential question you all should try to answer at the end of your notes when you write your summary is, how can we use stoichiometry to determine the amount of products and reactants in a chemical reaction? So here we're about to see the application of stoichiometry when we analyze a chemical reaction. Again, as we go through this video, I encourage you all to pause at any moment when you need extra time to take notes on what's on the slide. And that is indicated by this little handwriting icon in the top right corner. Okay, so these are the steps we're going to use to solve stoichiometry. Again, I encourage you all to pause the video and write these steps down all at once, and then you can play it again, and I will show you as we go through this problem. Okay, so starting with step number 1 is balance the chemical equation. So here we're going to use this chemical equation of carbon and oxygen combining to form carbon dioxide. And as we learned in the last video, this is a synthesis reaction. So if I want to balance the chemical equation, again, I'm looking at the number of carbon atoms on the reactant side and comparing it to the carbon atoms on the product side. You see those are balanced, however, my oxygens are not balanced. So I'm going to add this 2 as the coefficient here in front of carbon monoxide. And I'm going to now have 2 carbons and 2 oxygens, which means I need to add a 2 in front of this carbon here. So that is my first step. My second step is to determine the starting unit and write in the numerator of a fraction over 1. So this is very similar to our dimensional analysis step. So this problem says, how many grams of carbon monoxide are produced from the reaction above if it starts with 3 grams of carbon? So I'm going to underline that there, starting with 3 grams of pure carbon. So my first step, I'm going to write my starting unit, 3 grams of carbon over 1. Then I'm going to determine the ending unit and write it in the numerator of a fraction over 1. And I'm going to leave space in between my starting unit and my ending unit to do some math calculations there. So my ending unit that I know I want to get to, if I read the problem again, how many grams of carbon monoxide? So I'm looking for blank grams of CO. So I've got my bookends here. I've got my starting unit and I've got my ending unit. So that's step number 3. Step number 4 is to multiply or divide by unit conversion factors to get the units 2 units of moles and to cancel out the original units. So again, just to review, when we are going from grams to moles, we are dividing by the molar mass, which we get from our periodic table. So when we divide by our molar mass, that is actually the same thing as multiplying by our molar mass in the denominator of a fraction. So rather than dividing 3 by 12, I could actually just multiply 3 times 1 over 12. And that is the molar mass of carbon. And I will just clarify that for you all right here. I got that from the periodic table. So again, 1 mole weighs 12.01 grams on the scale. So 1 mole of carbon weighs weighs 12.01 grams on the scale. So this allows me to look at the diagonal across here, and I can cancel out my original units of grams, and now I am in units of moles. So I have successfully made this jump over from grams to moles, and I've completed step number 4. Step number 5 is multiplying by the chemical reaction's molar ratio. So in this chemical reaction, we are starting with carbon, and we are trying to use the amount of carbon we have to determine how much carbon monoxide we're going to have. So what I'm going to look at is how many carbons I have for every carbon monoxide atom in this chemical reaction. So you can see I've got 2 carbons, and that is giving me 2 carbon monoxides. So my molar ratio, I'm going a different color here, is for every 2 moles of carbon monoxide, and I'm going to write moles here too, I have 2 moles of pure carbon. And notice how I also want to match up the elements so that they are matching up across that diagonal. So I can actually cancel those out as well. So now I have moved from moles of carbon, or just pure carbon here, right? Again, look at across the diagonal, make sure they line up. And I am in units of moles of carbon monoxide. So that is step number 5. Step number 6 is to multiply or divide by unit conversion factors to get to the ending units. Okay, so we have gone from grams to moles, and now we need to go back from moles to grams to get to grams of carbon monoxide. So this time I'm going to multiply by the molar mass, and I'm actually going to use a different color here. So instead of using carbon's molar mass, I'm actually going to use carbon monoxide's molar mass, because I am now in units of moles of carbon monoxide. I'm going to multiply by carbon monoxide's molar mass. Which is 28.01 grams CO. Okay, so again, all I did to find that molar mass is add the molar mass of carbon with the molar mass of oxygen. Molar mass of carbon is 12.01. I rounded up the molar mass of oxygen to 16 to get 28.01 grams of carbon monoxide. So now I can cancel out my units of moles of carbon monoxide. Again, looking across that diagonal here. And I have successfully made it into my units of grams of carbon monoxide. So I am not quite done yet. I still do need to, let me make sure I erase that so y'all can see a little bit better. Just redraw a little bit here. Okay, so again, I am multiplying all these fractions across. I have canceled out these units here. And I'm left with units of grams of carbon monoxide. However, I still do need to multiply these numbers in the numerator and the denominator together. So I'm going to simplify this. And I've got a 3 right here times 1 right here times 2. Got these in the numerator times 28.01. Extend that a little bit. And the only unit left I have is grams of carbon monoxide. So I'm going to add that unit in there as well. And on the denominator, I've got a 1 times a 12.01 times 2 times 1. At this point, I'm just plugging this into the calculator. If it's helpful to you, put some parentheses around the numbers in the numerator and the numbers in the denominator to keep your order of operations straight. But go ahead and take a moment to yourself. You can pause the video to calculate this on your own. Plug it in your calculator and make sure your answer matches up with mine. And you should get something close to about 6.99 grams of carbon monoxide, which we're just going to round that up to 7 grams of carbon monoxide are formed from the reaction with starting material of 3 grams of pure carbon. So hopefully these steps help you lead to this answer. Again, I don't expect you all to get the exact same answer as I do, but as long as it's somewhere in this range, that is perfectly fine. And I look forward to discussing this more with you all in class coming up.